Well, welcome back to part 2 of solving systems of inequalities. Let's move forward with a couple examples of solving systems of inequalities. Let's look at our system this time. We have y is greater than x minus 1. That one is already in slope-intercept form, so we're in good shape with that one. We're just going to graph that one as we see it. The next one, though, is negative 4x plus 2y is less than or equal to 10. That one we have to do some work to get it prepared and make it easiest for us to graph on our coordinate graph. So I have the problem written over here. So our first step is let's move our 4x to the other side by adding 4x to both sides. Our problem then says 2y is less than or equal to 4x plus 10. Now, is that in proper form? Is this in slope-intercept y equals mx plus b? It is almost there. We don't want 2y. We only want 1y. So to get 1y, we must divide everything by a 2. So these cancel out. We have y is less than or equal to 2x plus 5. So we have our second inequality, which we will graph using the equation form, but shade based on the inequality. Let's go back to our original problem. Y is greater than x minus 1. We're going to start at a negative 1. We have a positive slope of 1, so we're going to go up 1 and over 1, put a dot, up 1 and over 1, put a dot, up 1 and over 1 and put a dot, and it continues in that format. We now know that we have a slope that's going in this direction, okay? And we're saying that we are going to shade above that line because it is greater. So I'm going to shade everything that's in this part of the graph up here. This would be the shading for y is greater than x minus 1. Okay? Let's take a look at our second graph. Y is equal to 2x plus 5. We're going to go up to a positive 5. Mark it right here. Okay? Our slope this time is up to 1, 2, and over 1, up 2 and over 1, up 2 and over 1. So now we have a graph, and this time we can go down 2 and over 1 also, down 2 and over 1. Now notice, we are going to have a solid line this time. Okay? And so we're kind of going in shape like this. And we are saying this is less than, so we are going to shade below this line. Okay? Below. So we're going to shade down here. And it's all down here for the second equation. But notice what we see. What we're going to find is this area in here is the common area and would be our solution for this system of equations. So let's test it. Let's pick one that's very easy. Our origin 0, 0 is right in this funnel shape where we have common shading. Let's put a 0 in here. Is 0 greater than 0 minus 1? Is 0 greater than negative 1? Well, that works. So that's a check. That one works. How about if we put a 0 in here? We would put negative 4 times 0, which is 0, plus 2 times 0, which is 0. So we have 0 is less than or equal to negative 10. And that one works also. Okay? So what we're looking at, again, as a recap, we are focusing on finding the system of equations that will give us the solution for an inequality that's going to give us the overlapping shading areas that would satisfy both of these equations. And this is the area for this problem here, the double shaded area. Thanks and have a good day.